the inverse function of function f is denoted by a symbol f. It looks like power by -1, but it is not power by -1. It's not reciprocal. Here, well, a power by -1 example for inversible functions. For example, if f of x is equal to square root of x, the inverse function is going to be g of x is equal to x squared. For example, f of 4 is square root of 4, which is 2, and g of 2 is equal to 2 squared, which is 4. So those two functions, the inverse functions, undo what the function has done. To find the inverse function of a function, we are going to follow the steps. First, replace f of x notation with y. Create the equation in terms of yx. On the second step, exchange x and the y value. Instead of x, you put y, and instead of y, you put x. Then you solve for y. If the equation does not define y as a function of f, the function f does not have an inverse function, and the procedure ends. If this equation does define y as a function of x, the function f has an inverse function. If f has an inverse function, at the last step, replace the y value with its f inverse, and we can verify the result by finding f of inverse of x is supposed to be equal to x, and inverse of f is supposed to be equal to x. We're going to give an example. Example 1, f of x is 1/2 x minus 4. So step 1 was, instead of f of x, we put y is equal to 1/2 x minus 4. On a step 2, instead of y, we're going to put x, and instead of x, we're going to put y. On step 3, we're going to solve for y. To solve for y in this expression, we have to add 4 to both sides, so x plus 4 is equal to 1/2 y. And finally, to solve for y, we need to multiply all sides of this equation by 2. And this 2 is going to cancel that denominator here. Or we end up having y is equal to 2x plus, and I'm going to distribute that to 2x plus 8. As step 4, we're going to say the inverse function of x is equal to 2x plus 8. Check. Is f of inverse of x equal to x? Is that true? Well, f has a construction of 1/2 the argument, and the argument is the inverse function, minus 4. Well, 1/2, the inverse function is 2x plus 8 minus 4. Distribute the 1/2. 1/2 times 2x is x. 1/2 times 8 is 4. Minus 4. And we see that the result is x, which checks. We have to do inverse function of f of x also. Is the opposite true? And the inverse function is 2x plus 8, so I'm going to put 2 times f of x plus 8. And twice f of x was 1/2 x. minus 4 plus 8. Distribute the 2. 2 times 1/2 x is x. 2 times negative 4 is negative 8. Plus 8 is indeed equal to x. So we have worked correctly, and the inverse function is 2x plus 8. Another example, f of x is equal to x to the third plus 1. Remember, step 1 is going to be replace f of x with y. Step 2 is going to be exchange x and y values. Step 3 is solve for y. Y cubed is equal to x minus 1, or y is equal to cubed root of x minus 1. Step 4, we replace y with the inverse notation. Inverse of f is going to be third root of x minus 1. Let's check. Is it true that f of inverse f of x is equal to x? Well, f is x cubed, so in this case that's going to be the inverse function of x powered by 3 plus 1, or that's third root of x minus 1 powered by 3 plus 1, and here the cube root and the 3 cancels out, and that will be x minus 1 remaining here plus 1, and indeed the answer is equal to x. One more check. Inverse f of x, is it equal to x? And the inverse function is cubed root of x minus 1, so I'm going to put f of x minus 1. That is cubed root of f of x. F of x is x cubed plus 1, and there is that extra minus 1 here. Those 1 and negative 1 cancel out, and cubed root of x to the cubed is equal to x, so it checks again. Now I'm gonna stop checking because I know I work correctly, but I would please ask you to check when working at home. The next function, f of x is equal to square root of x to the 5, x plus 5. Step 1, replace f of x with y. Step 2, replace y with x and x with y. Step 3, solve for y, so I'm gonna square both sides. X squared is equal to y plus 5. Solve for y. Y is equal to x squared minus 5. And as a step 4, I'm gonna write in inverse notation. Inverse of f is equal to x squared plus 5. I'm gonna circle my answer. Something that I forgot on the previous example, so I'm gonna circle my answer in the previous example also. Another example, again, step 1, instead of f of x we put y, and third root of x plus 1. Step 2, exchange y and x. X is equal to third root of y plus 1. Step 3, solve for y. third root of y is equal to x minus 1. Power both sides by 3. To cancel the third root. So I'm gonna continue over here. It's gonna be y is equal to x minus 1 cubed. And step 4 is going to be write your answer in interval notation, inverse notation. Cubed. Circle your answer. Example 5. Again, step 1, replace f of x with y. Step 2, exchange y and x. Step 3, solve for y. I'm gonna add 5 to the other side. I'm gonna multiply both sides by y. So I'm gonna multiply by y to be able to cancel this denominator. So 3 is equal to y times x plus 5. And then I'm gonna divide by x plus 5 to finally solve for y. I'm gonna put the answer here. Y is equal to 3 divided by x plus 5. Finally, step 4, use inverse notation. The inverse function is gonna be 3 over x plus 5. Circle your answer. With this, I'm gonna stop this video.